Welcome to the course of Machine Learning with hands-on experience in Python and R in data science. This course has been designed by the professional data scientists so that they can share our knowledge and help you learn complex theory, algorithms, and coding libraries. This course is fun and exciting, but at the same time, we dive deep into machine learning. It is structured the following way under 10 knowledgeable parts. First, this video shares some important knowledge about Part 1 data preprocessing.
Hello and welcome to Part 1 Data Preprocessing. So I had to start with this part because this is a crucial step in the journey of making a machine learning model. If there is no data preprocessing, your machine learning model won't work properly. So it's like preparing a journey. Imagine you are about to go for a long journey. Well, you have to prepare your itinerary, book your flights, book your hotels, and pack your luggage. That's definitely the boring part before the trip. But then when everything is well prepared and you're ready to go, your trip might be amazing. Well, it's the same for our machine learning journey. We have to prepare some stuff in order to make sure that we build our machine learning models without any issues. And the stuff that we need to prepare for our machine learning trip happens to be data preprocessing. So I have to be honest with you, this is the boring part, but we are only doing this so that we get the maximum fun later in this course when we make all the machine learning models. So trust me, we have to do it, because if we don't do it, we will miss out on all the fun of machine learning. So I did the best I could to gather in this part all the essentials of data preprocessing, and even if I made sure to make it as simple as possible, there is all you need to know about data preprocessing. There's all you need to know how to do to prepare any data set for any machine learning model. So excluding this one, there are going to be 8 tutorials in this part, so hold on to them, and I promise you that we will get a lot of fun once we start our machine learning journey.
Hello and welcome back to the course on machine learning. In today's tutorial, we will show you how to download the datasets for this course. Now, as you can already probably tell, the course is large. It's got over 200 tutorials and over 35 hours of content. And as you can imagine, with that much training, we will have to have lots and lots of datasets. And that's why we have decided to place all of the datasets on their own separate page. So in order to get the datasets, you will need to go to www.superdatascience.com/machine-learning. So that's 2 words, machine-learning. The website is superdatascience.com. And here you'll see a whole page dedicated to this course with lots and lots of data sets available, which you can download and install onto your machine in order to follow along with the tutorials. So today we're going to start off with the very first one as an example, and then throughout the course you'll be able to download the right data set for every single section, depending on the section that you're doing. So today we're going to start off with the data preprocessing dataset, and here also we're going to get right away the machine learning A to Z template folder. It's a special template folder that we've created for you to help you store these datasets in a hierarchical fashion so that you can navigate all of these datasets better, and that so that they're all in the right place, so you have a very orderly folder structure on your own machine. So go ahead and download these two. These are both zip files, so if you just click there and click there, you'll see that these have been downloaded. The first one's very small, it's just empty folders, and then the second one is the dataset for the section. And then whenever you get to a new section, we'll of course remind you at the start of the section, but basically what you'll need to do is just download the right data set for your section that you're in. But more on that later. Let's move on to today's section. So we've got these 2 zip files here. All you have to do is take the machine learning A to Z template folder and unzip it to the location where you want it to be. So I'm going to unzip mine to the desktop. I'm going to right click and I'm going to extract, just click extract here. So that's on Windows, on Mac, similar thing, just unzip the file, unzip the zip folder. So there we go, there's a folder, and now if you look inside here, you'll see that you've got a very nice, neat structure. You can go inside any one of these sections, for instance, clustering, you'll see the title of the section, and then you can go into any one of these. And again, these are empty for now, and that's because we haven't done those sections. As you go through the course, you will populate these folders with their respective data sets. Now we're going to go into data preprocessing, so part 1. And here we've got this whole empty folder. So we don't worry about the folders with the dashes. Those are just titles to remind us where we're located inside the folder structure. So just go ahead and take your data pre-processing zip folder, drag it here, and right click and just say extract here. And again, just go inside data pre-processing, because we don't want it to be in its own separate folder. Just take all these files, copy them, so right click, actually cut them, and then paste them here. So basically you don't need this folder now because it's empty. Delete that folder. You can delete this zip file because we don't need it anymore, and you can delete this zip file as well. So there we go. Now we have our machine learning A to Z template folder. You can remove actually let's do that. We can remove template folder from there. We can just say machine learning A to Z. And if you go in here, you'll see data pre-processing, and there you go. So you've got your data set ready for the section, plus you already have all of the templates which you will be creating with Hadlan throughout the tutorials in this section. And so that's pretty much what you need to do for every single section that you go through. And again, we'll remind you. And the reason for this structure is, so why did we structure it like this? Why did we, for instance, not include all of the data sets right away inside these folders for you, right? That feels like it would be more convenient. But at the same time, there's a couple of reasons. So the first one is that in case we need to update something, in case we need to update a certain section, like this section, for instance, we need to update the dataset. Well, in that case, if we had to update it and then re-upload the whole folder, that would take time. That would mean the course would not be available for longer, or that means while we're updating, a lot of people would be getting the wrong dataset, and we don't want that. So if we want to update something now, we can very quickly just update that one zip file on the website, and that's very quick for us to do. And the second reason is, of course, size. If we had put all of the datasets in here right away, this folder would be massive. So it's much more efficient to download just a section that you're doing and then proceed with those tutorials. So there we go. That's how you get the datasets. And now I'll hand you over to Hadlan, who will take you through today's dataset.
So what is this dataset about? This dataset contains 4 columns: country, age, salary, and purchased, and 10 lines, 10 observations. And basically this contains informations of customers of some company, and the first 3 columns are informations of these customers, like the country, the age, and the salary. And the 4th column, purchased here, tells if yes or no the customer bought the product of the company. So we have to distinguish something very important here that we will distinguish for the rest of the course. It's the difference between the independent variables and the dependent variables. So the independent variables are the first 3 columns, country, age, and salary, and the dependent variable is purchased here, the 4th column. And in any machine learning model, we're going to use some independent variables to predict a dependent variable. So that means here that with these 3 first columns, these 3 independent variables, we are going to predict if yes or no the customer purchased a product. Okay, so that's the first distinction that we really need to understand. And it's very important to do this section because the data preprocessing steps that we're going to do in this section, we will have to do it for all the machine learning models we are going to make. So it's really essential to know how to manage this. But don't worry, it's going to be very simple, and besides, I'm going to give you at the end of this section a template that will allow us later to pre-process the data in a flashlight for all the machine learning models we're going to make. So I look forward to starting these steps with you, and until then, enjoy machine learning. Hello and welcome to this tutorial. So in the previous tutorial we got our dataset for this section, that is the dataset we're using to learn how to pre-process any data when we make a machine learning model. And now we are ready to start the data preprocessing steps, and the first step is to know how to import the libraries. Okay, so we're going to split this tutorial in 2 parts, the first part in Python and the second part in R. So let's start with Python. So I'm going to jump here to Python. So here I created a new file on Python that I called data preprocessing templates, because we're starting to build our template. And here is the first step, importing the libraries. Okay, so what is a library? A library is a tool that you can use to make a specific job. And what's so cool about this is that you just have to give some inputs, then the library will do the job for you and it will return some outputs that is exactly what you are looking for. So that's really cool and useful, and we are gonna mostly use libraries during this course to make our machine learning models the most efficient as possible. Okay, so we're gonna use many libraries during the course to make our machine learning models, but there are 3 essential libraries that we're gonna use every time. So the first step of our data preprocessing template is to actually import these 3 essential libraries so that we don't have to take care of that later. Okay, so let's import the first one. The first one is NumPy. And to import a library in Python, you have to type import NumPy, so that's the name of the library. And then you can make a shortcut to use it faster when you use it in your code later. And to use the shortcut, you add as np. Okay, so the name of the library is NumPy and the name of the shortcut is np. Okay, and now what is this NumPy library? So this NumPy library is a library that contains mathematical tools, and basically this is the library that we need to include any types of mathematics in our code. And since of course machine learning models are based on mathematics, then we will absolutely need NumPy from time to time to do them, but not all the time, you'll see. Okay, so that's the first library, and now let's import the second library, which is really essential, and it's called matplotlib. So that's the name of the library. And actually, in this library, we're gonna import a sub-library, which is pyplot. Okay. And as a shortcut name, we're going to use plt. Okay, plt. So what is this matplotlib.pyplot? So as you probably guessed, this library is a library that is going to help us plot nice charts. Really, anytime you want to plot something in Python, you use matplotlib. It contains very intuitive and useful tools, and you're going to see why later in this course. Okay, so that's for the 2 first libraries, and now the last library that we need is the pandas library. So let's import it, and I'll just explain what it does. Import pandas as PD. Alright, so PD is the name of the shortcut for this library. So the pandas library is really the best library to import datasets and manage datasets. So you're going to see that it's really intuitive as well, and we're going to use Panda most of the time to import our datasets, and we will sometimes use it to manage them. So I'll show you later in this course. And now all we need to do is to select this block of code and press Command and Control plus Enter to execute. Done. Here, as you can see in the console, the 3 libraries are imported. And that's it for Python. These are the 3 essential libraries that we need. So now we will jump to R, and you're going to see that it's very quick in R, because actually we won't need to import any library. Okay, so here we are on R, and so as I just said, here we don't need to import the libraries. Because as you can see, the library are here in the Packages tab, and here is the list of all the libraries. So we might have a different list because I installed a lot of packages before, and if you started R for the first time, you might not have some libraries that are here. For example, I know that lmstatlearn, I installed it, so you might not have it, but it's normal. We will install it later in this course. So these are all the libraries, and all the essential libraries that we mostly need are selected by default. So here on R, we don't need to import any libraries. However, later in this course, we will use some specific libraries that complete a specific job, and I'll show you how to install them and include them in your code, that is to activate them, but we are not here yet, and so far we have everything we need. Okay, so that's it for this tutorial. Now you know how to import libraries in Python and know where your libraries are in R. So that's the first useful thing to know, and now we're ready to move to the next step, which will be to import our dataset. So I look forward to seeing you in the next tutorial, and until then, enjoy machine learning! Hello and welcome to this tutorial. In the previous tutorial we learned how to import the libraries, and in this one we're going to learn how to import the dataset. So this time we're going to have to do it both in Python and R, so let's start with Python. I'm going to jump straight to Python, here we are. Okay, so the first thing to do before starting to import a dataset is of course to set a working directory. And that's the case anytime you want to import a dataset, you have to specify a working directory folder, and that must be the folder that contains your dataset. So to set this folder as working directory, it's very simple. What you need to do is to go to File Explorer here, because this is the window where you can go to all the files in your computer. So right now, as you can see, I'm on my desktop, and this is the Machine Learning AZ folder on my desktop. So let's go inside. Inside this folder we have the 10 parts, and we are in part 1 data preprocessing. So let's open the subfolder. Here we go, and this folder contains just one section. Let's open it, and that is the folder we want to set as working directory. And why is that? It's because it contains the data CSV file. You know, you can set any folder you want as working directory as long as they have the data CSV file. So once you reached this right folder in the File Explorer window, then you have two options. For those of you who are working on a Mac, well, you have this little button here to set this folder as working directory, and you just need to click on it, as I just did, and now this folder is set as working directory. So that's the first option. If you have this little button here on your screen, well, you can click on it to set the folder as working directory. And then for those of you who are on Windows, then this option here might not work for you. So what you need to do is also very simple. You just need to save your Python file into the folder that contains the dataset data.csv. And to save your Python file, you just need to click on here. And if you did not save it before, well, you will automatically have a window that will ask you to choose where to save your file. And once this Python file is saved in your folder that contains the dataset data.csv, well, what you need to do is simply click on this little button here, which as you can see is to run the whole file, and that will automatically set your folder as working directory. And actually there is a shortcut to do it even faster. It's, instead of clicking on this button here, you just need to press F5, and that will execute the whole file and set your folder as working directory at the same time. So you have the two options. For Mac users, you can click on this button here, and for Windows users, you save your file in the folder that contains the dataset, and then you execute the saved file by pressing F5 even if the file is empty. And for both of you, that will set your folder as working directory. So as I explained in the previous tutorial, the best library to import a dataset is pandas. So right now we're going to use pandas to import the dataset. We're going to declare a new variable that is going to be the dataset itself, and we're going to simply call it dataset. Okay, then equals, and now immediately we will use panda to import the data.csv dataset. So what we have to do is use the shortcut pd, that is the shortcut for pandas, then you type dot, and then read underscore csv, parenthesis, and in the parenthesis you input the name of your dataset, which is, of course, data.csv. Quote, parenthesis, all good. That's perfect. So let's select this line here and press Command and Control plus Enter to execute. Okay, as you can see in the console, the line of code was executed correctly, so that means that we correctly imported our dataset. And if we go to Variable Explorer now here, we can see that the dataset is actually here. And if we double click on it, here is the dataset. So we have our 4 columns, country, age, salary, purchased, and we have our 10 observations. So you have to understand that indexes in Python start at 0. So here the first observation index is 0, but that's Python. We're going to see that in R indexes start at 1, but in Python you have to get used to the fact that indexes start at 0. So we have our 10 observations. If you're not very comfortable with the scientific notation, we can change that. Actually, I would prefer, the float number itself. So we're going to click on Format. So here we're going to change the 3 to 0 to have no decimal after the comma. And we're going to change the G to F to have a float. And when we click on OK, we have our salary this way, which some of you might prefer. Okay, so we're fine with our dataset. Now let's click on OK. And now there is something very important to understand in machine learning in Python. It's that we have our dataset, but we need to distinguish the matrix of features and the dependent variables vector. So right now what we're going to do is we're going to create the matrix of features. That is, if I go back to my dataset here, we're going to create the matrix of the 3 independent variables. So basically we're going to put in a variable x, there's going to be the matrix, all those observations here. So basically the 3 columns here, the 3 first columns, which are the independent variables columns, and the 10 lines, which are the 10 observations. And then we will create the dependent variable vector, which is going to be the last column here with the 10 observations. Okay, so let's do this. Let's click on OK, and let's start by creating our matrix of features. Okay, so we're going to call it x equals, and then we're going to use the dataset variable that we just created, then dot, and we're going to take all the columns of features, the columns of independent variables, and to do this we're going to type iloc, then brackets, and then colon, comma, column -1. So don't worry about that, I'll explain everything. And then dot values. Okay, what did we just do here? By putting the colon here, that means that we take all the lines, because what's on the left of this comma here is the lines of the dataset, and what's on the right of this comma are the columns. So by putting this colon here, that means that we take all the lines. And then at the right of this comma, we typed column -1. So that means that we take all the columns except the last one. -1 means that we don't include the last one, and column means that we take all the columns. So column -1 means that we take all the columns except the last one. Okay, and dot values means that we want to take all the values. That's just a Python syntax, and that's how it works. So you're gonna see, let's select this line and execute. Here it is. The X matrix was imported correctly. And now let's type here X in the console. And as you can see, we have our 3 first columns, the 3 first columns of the data set, as you can see. Here, the column country, age, salary, country, age, salary. And we don't have the last column, purchased. So that's good, that's our matrix. That's the matrix of features, the matrix of independent variables. And you'll understand step by step why we need to do this in Python. Okay, so I'm going to click on OK here, and now what we have to do is to create the dependent variable vector. So we're going to call it y equals, and now we're going to do exactly the same thing. So I'm going to copy this line here and paste it here, and we want to take the last column, so it's going to be the same. We're going to take all the lines here with the column here, and here at the right of the comma we are going to choose the last column, which is, so we have to input here the index of the last column. So let's go to our data set and find out what it is. So as I said earlier, indexes in Python start at 0. So index for country is 0, index for age is 1, index for salary is 2, and index for purchased is 3. So here, since we want the last column, we're going to input 3. And we'll be fine. Let's select this line, Command and Control plus Enter to execute. Here it is, here's the Y. Let's type Y here and press Enter. And here it is, we have our last column. No, yes, no, this is the purchase columns that I remind tells if yes or no the customer bought the product. Okay, so that's it for Python. We imported the dataset and prepared the data correctly. Now we're going to jump to R and see how we have to do it. And you're going to see that it will be much more simple because we won't have to make a distinction between the matrix of features and the dependent variable vector. So let's go to R. Okay, so here I am on R, and as for Python, we need to set the working directory. So to do this, we have to go to Files here. Here I'm on my desktop. So let's go to our folder Data Preprocessing Part 1. Here it is, Section 2. And this is the right folder that contains the dataset data.csv. So this is the folder that you want to choose to set as working directory. And now to set this working directory on R, you need to do one more thing. You need to click on this More button here and click on Set as working directory. And here it is. Now we know that this is the right working directory and we are ready to start importing the dataset. Okay, so to do this in R, what we need to do is very simple. We will just need one line of code. So as in Python, we're going to call it dataset. So that's the variable that will be the dataset itself. And now to import the dataset is very easy. You need to type read.csv, and then in parentheses, you just type the name of your dataset in quotes. So here you have to type data.csv. And that's it. That's all you need to do. So now we're gonna select this line of code and execute. Okay, so let's have a look at our dataset. To do this, you just need to click here on the dataset and it just displays here. Okay, so we have our 4 columns, country, age, salary, purchased, and our 10 observations. And what's interesting to see here is that unlike Python, indexes don't start at 0 but at 1. So that's why the first observation starts at 1 here and ends at 10. So that's the second distinction you have to understand between Python and R. Of course, you don't have to program on both, you can choose the one you prefer. But if you want to program on both, as I usually do, it's good to have this distinction in mind. Okay, so we have our dataset, it's all fine. And as I just said, here we don't have to make the distinction between a matrix of features and a dependent variable vector, and this will make perfect sense for you as we go along with this part 1 data preprocessing. You'll perfectly understand why in the next tutorials. Okay, so that's it for the importing the dataset step of the data preprocessing phase. So that's it for this tutorial. I look forward to seeing you in the next one, which will be to learn how to take care of missing data. Because sometimes your dataset will contain missing data and you have to take care of this, and that's what we're going to learn in the next tutorial. So I look forward to seeing you there, and until then, enjoy machine learning. Hello and welcome to this tutorial. In the previous tutorials we learned how to import the libraries and to import the dataset, and now we are finally going to start preparing the data so that our machine learning models run correctly. And the first problem that we have to deal with is the case where you have some missing data in your dataset. And that happens quite a lot actually in real life, so you have to get the trick to handle this problem and make it all good for your machine learning model to run correctly. So let's have a look at the dataset. Here I'm going to my Google Sheets tab. Okay, so here is the dataset, and as you can see there is 2 missing data. There is 1 missing data in the age column here for Spain, and 1 missing data in the salary column for Germany. So how can we handle this problem? Well, the first idea is to remove the lines, the observations, where there is some missing data. So what we could do is to remove this line and remove this line. But that can be quite dangerous, because imagine this dataset contains crucial information. It would be quite dangerous to remove an observation. So we need to figure out a better idea to handle this problem. And another idea, and that's actually the most common idea to handle missing data, is to take the mean of the columns. So here we are going to replace this missing data here by the mean of all the values in the column age. And that's the same for every feature that contains missing data. We replace this missing data by the mean of the values in the column that contains this missing data. So that is the strategy we're going to use, and let's do it right now on Python and R. So let's start with Python. I'm going to jump straight to Python right now. Here it is. Okay. So as usual, we are going to take a library to do this job for us. We're not going to implement a function mean ourselves. We will, make it the simplest as possible. So the library that we're going to use for this one is called scikit-learn preprocessing, and from this library we're going to import the imputer class. So let's do this. So to import this library in Python, we need to type from sklearn dot and then preprocessing. Here it is. Import imputer. Okay, so I'll just explain what this is. So sklearn is scikit-learn actually, and it contains amazing libraries to make machine learning models. And from scikit-learn we import this preprocessing library that contains a lot of classes, methods to preprocess any datasets. That is exactly what we're doing right now. And from this library we are importing the imputer class, which will allow us to take care of those missing data. Okay, and now that we imported the class, we now need to create an object of the class. So to create this object, we are going to start giving a name to this object, and we're going to call it imputer. Let's make things simple. Imputer equals, and now we're going to call the class that we just imported, which is imputer with capital I. And then now a good thing to do is to press Command I to see the object inspector here. Command I is like command inspect, so we're inspecting the imputer here to get some info about this class and see what parameters we have to input. Okay, so here we have the parameters, and the first parameter is missing values. So in parentheses we're going to input missing values, and so for missing values we are going to choose NaN. And why is that? It's because when we go to our dataset in Variable Explorer here, and we go to dataset, we can see that the missing values are called NaN. So by putting NaN here with capital N's actually, it will recognize the missing values to take care of. Okay, so let's press OK. Now, what is the next parameter? The next parameter is strategy. Okay, so that's good. Let's add strategy here. Equals, and what strategy are we going to use? Of course we're going to use the mean strategy because we're going to replace the missing values by the mean of the column. So let's choose here mean, and actually mean is the default value for the strategy parameter, so we wouldn't need to input strategy equals mean, but let's put it anyway to understand what we're doing. And then what is the next parameter? The next parameter is axis. Okay, so if axis equals 0, that means that we're taking the mean of the columns, and if axis equals 1, that means that we're taking the means of the rows. So of course it makes much more sense to take the means of the columns because it's the mean of the feature. So of course we're going to choose axis equals 0. Okay, good. And we're not going to take care of the rest of the parameters, they're not important. We have the essential parameters here, and we're ready to go to the next step, which is to fit this imputer object to our data X, to our matrix of features X. So that's what we're going to do right now. Okay, so to fit this imputer object to our matrix of feature X, we need to do this. We're going to type imputer dot fit. You see, it's quite intuitive. And then in fit, of course, we're going to input what we want to fit the imputer to, which is X, of course. However, we're not going to fit the imputer on the total matrix. Let's have a look at the matrix again. The matrix is here, as you can see, and we're not going to fit the imputer to all the matrix. We are only going to fit it to the columns where there is some missing data. So here we're going to add some brackets here, and as usual we want to take the whole column, so we will take all the lines by putting column here, then comma, and then here that's where we are going to choose the right column. That means the column that contains missing data. So this column here is the second column and the third column, that is the age column and the salary column. So we need to put the indexes of this second and third column, and do you remember what indexes we have to use? Indexes in Python start at 0, so this column here has index 1 and not 2, and this column here has index 2. Okay, so here to input those two indexes, we're gonna type 1 column, and sorry about that guys, it's not gonna be 2 here, it's gonna be 3, and the reason for that is that the upper bound is excluded. So yeah, by putting 1 column 3 here, that means that we're taking indexes 1 and 2, but the lower bound 1 is included. So you just have to get used to this syntax in Python, and you will soon be much more comfortable, but for now I agree that it's sometimes quite confusing. But that's how it is. X, taking all the lines and columns 1 and 2, indexes 1 and 2. Okay, that's all to fit the imputer object to our matrix X. So now what is this imputer.fit x13? It's actually the same object imputer that was fit to the matrix X. So what we need to do is to add imputer equals imputer.fit x to make our imputer object fitted to the data X. So now by adding this imputer equals that, the imputer object is now fitted to the matrix X. Okay, and now we just need to do one last thing, which is to replace the missing data of the matrix X by the mean of the column. So to do this, we need to do X, bracket, then we need to select the columns where there is some missing data. So as usual, column to take all the lines, then comma, And then the same, we need to take the two indexes of the columns that contain missing data, which are indexes 1 and 2. So here, it's the same as here, we type 1 colon 3, okay? Equals, and then we're gonna use our object imputer, and we're going to apply the method of the imputer object, which is transform. So here, the transform method is here, and this is the method that is going to replace the missing data by the mean of the column. So, and here what we only have to do is to take the two columns of the data x and put it in the parentheses here. And that's it. That's how you take care of missing data with Python. So now we're going to select this block of code, execute. Okay, all good. You can see that the code ran properly. And now let's look at x and let's see what happens. X, enter. Great, the missing data were replaced by the mean. The salary that was missing was replaced by $63,777, and the age that was missing was replaced by 38.7 years old. Okay, and let's check that. Let's check if it's the right values on Google Sheets. Okay, so here on Google Sheets, so the first missing value was the salary here. So let's compute the average. So we have to type equals average. Here it is. We take all the observations of the salary column, parentheses, enter, and here's the average. So it's 63,777. Let's check on Python. Yep, here it is. It's the right value. It's the mean. So it was replaced correctly. And now let's check it for the age. Let's remember 38 years old, 0.7. And let's go to Google Sheets. Let's compute the average here, equals average. Here we take all the values, parentheses, and 38.7, all good, that's perfect. Okay, so congratulations, now you know how to take care of missing data in Python. You can have fun and try to use another strategy. For example, you can take, let's go back to the object inspector. You can take the median strategy, which will replace your missing value by the median of the column. Or you can take the most frequent value of the column, which could also be a good idea depending on the context. Okay, so now we're going to do the same in R. It's going to be quite the same, only we're going to have to handle the two missing data separately. Okay, so let's do this. First, we need to take our data set. So data set. Let's start by taking care of the missing value in the age column. So here we will need to take the age column, and to do this in R, we need to add a $sign here, and here we choose age. So by doing that, dataset $age, we're taking the column age of the dataset. Then we're going to add equals, and then we're going to add an if-else. So I'm going to type if-else here, then parenthesis. In the if-else function, you have to input three parameters. The first parameter is your condition, if condition. The second parameter is the value you want to input if the condition is true, and the second parameter is the value you want to input if the condition is false. So let's first input the condition. The condition is going to be is.na parenthesis dataset $age, and that's it. Is.na is a function that tells if the value in the function is missing or not. So by putting is.na dataset $age, we are checking to see if all the values in the column age are missing. So this will return true if the value in the column age is missing, and false if the value in the column age is not missing. Okay, so that's the condition. And now, the second parameter is the value that is going to be returned if the condition above is true. And of course, if the condition is true, that means that there is a missing value, and that means that we have to replace it with the average. So here we're going to input as a second parameter the average of the column age. Okay, and to compute the average in R, there is a simple way. We can type AVE, then dataset $age, because we want to take the column age, then comma, and then here we're going to add a function. So we're going to type fun in capitals, fun equals, then function x. This is still part of the R syntax. We're just making a function here, which is going to be the mean function, and then we have to specify what this function will be. And so this function is of course the mean, which is an existing function in R. So here parenthesis x, comma, And here we're just going to add na.rm equals true. And that means that we ask R to include the missing values when R will go through the whole column age to compute the mean of the values. Now we still need to close the parenthesis here, okay, and then comma. So that's it for the second parameter. And now we need to add the third parameter. And in your opinion, what is it going to be? Well, this third parameter is the value you want to return if the first condition is not true. That means that the value in the column age is not missing. So that means that the value exists. So here we're simply going to put dataset age. Okay, and that's done. By typing this, we replace the missing value in the column age by the mean of the column age itself. So let's select this and let's see what happens. So Command and Control plus Enter to execute. And here it is. It executed properly. And now let's look at our dataset by clicking on this tab here. And good, perfect. The missing value that was here in the age column was replaced by the mean of the column. Great. So now let's do the same for the salary. So we're just going to copy this, paste, and we're just going to replace age by the salary here. Here as well, here as well, and also here. Great. And now we have to be careful with something. It has to be aligned here, so we just have to do this, and same for here. This. Okay, and now we're fine. Now we're ready to select this code section here, press Command and Control plus Enter to execute. Here it is. Let's check our data set. And perfect, the missing value in the salary that was here was replaced by the mean of the salary column, $63,777. Okay, perfect, congratulations, now you know how to take care of missing data in both Python and R. That's the end of this tutorial, and I look forward to seeing you in the next tutorial. The next tutorial will be about categorical data, so we will learn how to encode categorical data. You will understand why we have to do this, so I look forward to seeing you in the next tutorial, and until then, enjoy machine learning. Hello and welcome to this tutorial. Okay, so we are halfway our data preprocessing phase. We learned how to import the libraries, to import the data set. We learned how to take care of missing data, and today we're going to learn how to encode categorical data. So the first thing that we're going to do is that we are going to explain why we need to do this. So I'm going to go to Google Sheets here to find my data set. And in this data set, we can see that we have two categorical variables. We have the country variable here and the purchase variable. These two variables are categorical variables because simply they contain categories. Here, the country contains three categories. It's France, Spain, and Germany. And the purchase variable contains two categories, yes and no. So that's why they're called categorical variables. And now you can guess that since machine learning models are based on mathematical equations, you can intuitively understand that it would cause some problem if we keep the text here in the categorical variables in the equations, because we would only want numbers in the equations. So that's why we need to encode the categorical variables, that is to encode the text that we have here into numbers. Okay, so in this tutorial we're going to encode these two variables, country and purchase. We're going to do it in Python and R, and you're going to see that the technique is quite different. So let's start with Python. Alright, so here we are on Python. So as usual, we're going to import a library that will do the job for us, and this library is going to be the same library as we used to take care of missing data. It's the sklearn preprocessing library. So let's just copy this and paste it here. But then we're not going to import the imputer, we're going to import something else, which is label encoder. Alright, so label encoder is a class from the sklearn preprocessing library. So exactly as we did when we took care of missing data, here we need to create a first object of the label encoder class. Okay, so I'm going to call this object label encoder. Okay, so since we're first going to take care of the country categorical variable here, I'm going to call this object label encoder underscore x, and then what I'm simply going to do is I'm going to call the label encoder class. Okay, so we simply need to do this. We simply need to create an object of the label encoder class. And then we're going to use this object on this column country here, which is our categorical variable. Okay, so let's click OK. Okay, so to apply the label encoder object on our column, we will type label encoder underscore x, so that is our object. Then we're going to take a method of the label encoder class, which is the fit transform method, and we're going to apply this method on x, but not the whole matrix x. We just want the first column, and I'm gonna let you guess what to put next. We need to put the index of the first column, and we know that indexes in Python start at 0, so the index of the country column is 0. So here we're gonna put bracket. We want the whole column, so we here put colon to take all the lines, then comma, and then we put the index, which is 0. Okay, so what we need to understand here is that by typing this line of code, we fitted this label encoder x object to the first column country of our matrix x, and all this returns the first column country of the matrix x encoded. So that means that if I select this and execute, you can see that the output contains the 10 values of the first column of our matrix x, but this time encoded. We no longer have the countries written in text, we have the encoded values of these countries. So now what we need to do is to take the first column here of the matrix x, put it here, so that the first column of this matrix x becomes this array of encoded values of the countries. Because as you can see, if I look at x right now, x, we can see that the first column contains the countries in text, France, Spain, Germany, etc. And now, if I select this line and execute, okay, and if I type x again, okay, now the first column of the x matrix has the encoded values. We can see that France is 0, Spain is 2, and Germany is 1. Okay, so by doing this, we encoded the country column. However, do you suspect any problem that could happen? I will let you think for 10 seconds of what problem could happen here, and I will tell you what this is. Okay, so the problem is still the same. Machine learning models are based on equations, and that's good that we replaced the text by numbers so that we can include the numbers in the equations. However, since 1 is greater than 0 and 2 is greater than 1, the equations in the model will think that Spain has a higher value than Germany and France, and Germany has a higher value than France. And that's not the case. These are actually 3 categories and there is no relational order between the 3. We cannot compare France, Spain and Germany by saying that Spain is greater than Germany or Germany is greater than France. This wouldn't make any sense. If we had, for example, the variable size with the sizes like small, medium and large, then yes, we could express orders between the values of this variable because large is greater than medium and medium is greater than small. But here it doesn't make any sense. So we have to prevent the machine learning equations from thinking that Germany is greater than France and Spain is greater than Germany. And to prevent this, we're going to use what are called the dummy variables. That means that instead of having one column here, we're going to have 3 columns. We're going to have a number of columns equal to the number of categories. So since we have 3 categories here, France, Spain and Germany, we're going to have 3 columns. Each of these 3 columns will correspond to one country. We're going to have the France column, the Spain column and the Germany column. And in each column there's going to be either 1 or 0. So for example, if we are in the France column, it's going to be 1 if the country is France and 0 if the country is not France. So let's do this. Let's create those dummy variables. To create those dummy variables, we're going to use another class because the label encoder only encodes the values without bothering if there is order or not. So we're going to use another class here, which is the onHotEncoder class. Cool name, right? OneHotEncoder. Okay, and as usual, we're going to create a onHotEncoder object. So I'm going to call it onHotEncoder equals, so that's the object, and here we're gonna call the class oneHotEncoder with the capitals, oneHotEncoder, and parentheses, because we're calling the class. And now let's inspect this class. So here I just tapped Command or Control plus I, which means inspect. And if I put that below, we have information about the oneHotEncoder class. Let's look at the parameters to see what we have to input. Okay, the first parameter is n values, so that's the number of values per feature. We don't really care about that. But an important parameter is the second one, categorical features. Specify what features are treated as categorical. So basically what it means is that we need to specify the index of the columns, that is the column of the categorical variable, which is the country column. It has index number 0, so here we are going to input categorical features equals, in bracket, 0. Alright, so that way we specify which column we want to one-hot encode the categories. Okay, so now our object is ready and now we need to fit it to our matrix X. So let's do this. It's really simple. It's kind of the same logic every time. We're going to type X equals because we want to transform X. Then we use our object oneHotEncoder.fit transform. Then in parentheses we type X, and we don't have to only take the first column of X because here we specified the 0 index, so that's fine. And then we just need to add to array in parentheses. Okay, so that will oneHotEncode the variable X, and you will see exactly what it's going to do. Okay, so now we must not forget to reselect and execute this line because we imported a new library which is the oneHotEncoder. So execute. Okay, and now let's select these two lines and execute. Alright, and now let's have a look at X. I'm gonna type X here. Or, okay, so maybe it's better to look at it from here. Let's look at it from here. X. Alright, I'm gonna change the format because I don't want all the decimals. So 3 is the number of decimals, so I'm gonna put 0 here to have 0 decimals. Let's click on OK, and here it is, we have 0 decimals. Let's open our dataset too. Okay, so as I told you, the first column here, country, was replaced by 3 columns, this column, this column, and this column, and then we still have our 2 columns, which is the age and the salary. So what I was explaining is that this first column here corresponds to France, this second column here corresponds to Germany, and this third column here corresponds to Spain. So here, for example, let's take the first line. We know that the first line that has index 0 is the country France. And since the first observation is France, then that means that this first column here is going to be 1, because this corresponds to the France column. Then since the second column is Germany, then it's going to be a 0 here because the first observation is France and not Germany. And same for Spain, the third column here is Spain, and it's a 0 because the first observation is France and not Spain. And that is how you encode dummy variables, by making sure that the machine learning models don't attribute an order into the categorical variables. Okay, so let's click on OK here. And now let's take care of the second variable, which is the purchased one. And now be relieved, we won't have to use oneHotEncoder. We will just need to use label encoder because since this is the dependent variable, the machine learning model will know that it's a category and that there is no order between the two. So for the purchased column here, which is the dependent variable, we are only going to use label encoder, and that's what we are going to do. So we're going to do it very quickly. I'm just going to copy this and paste it here. Then we have to create a new object here. So we're going to call it label encoder Y. We cannot use this object label encoder X because this was fitted to the X column here. So that's why we need to create a new object. And here we just need to replace the first column of X by Y, and same as here, Y. And let's not forget to replace X by Y here. And that's ready. We created our object of the label encoder class that will be fitted to Y and that will transform Y into an encoded variable vector. So let's select these two lines here and press Command and Control Enter to execute. Here it is. Now let's have a look at Y. Okay, so let's open the dataset first. You see that in the data set, the purchase column has the two categories yes and no. And now if we look at our vector y, it is encoded, and the label encoder class attributed 0 to no and 1 to yes. Okay, perfect. So congratulations. Now you know how to encode a categorical variable in Python. If you're still not very comfortable with the dummy variable concept, then don't worry, because there will be another explanation in the multiple linear regression section, where we will explain in much more detail the dummy variables by talking about the dummy variable trap. So that was the first explanation, but the intuition is maybe going to get better built later in this course in the multilinear regression section. Okay, and now let's move on to R. So here we are on R. On R it's actually much more simple, because we won't need to do a one-hot encoding, because we're going to use something very practical in R, that is the factor function, and the factor function will transform your categorical variables into numeric categories, but it will see the variable as factors. And you will be able to choose the labels of those factors, and due to this specific reason, we won't need to create 3 columns for each category. We will just transform the country column into a column of factors, and we're going to specify what the factors are. So let's do this. Let's start by encoding the country column. So we just need to take the column country, and to do this we type dataset $country equals, and then we use the factor function, factor, and in factor we're going to specify 3 things. So let's have a look at the factor function. To do this we click on F1. Okay, so this contains some info about the factor function. Let's look at the arguments. The first argument is the data that we want to transform into factors. So this is of course going to be our country column from our data set. Okay. Then the second parameter is levels, and that's the names of the categories in our country column. So let's add here levels equals, so we're going to write the vector of levels here, C parenthesis, and then we will input here our 3 categories. So that's France, Spain, and Germany. Alright, so by the way, C here is a vector in R. So by creating this C, France, Spain, Germany, we are creating a vector of 3 elements, that is France, Spain, and Germany. Okay, and the last argument that we need to input is labels, because we want to choose which number we want to give to France, to Spain, and to Germany. So we're going to add here labels. And then, since we transform our country categorical variable into factors, we don't really care what numbers to use. So let's use 1 for France, 2 for Spain, and 3 for Germany. So this has nothing to do with my preference. It's not because I'm French that I choose 1 for France. It is absolutely non-order relative. So it's just by default that I use 1 to 3. Okay, so that's it. I just forgot 1 parenthesis, and I think this should disappear. Yes, good. Okay, so the encoding of the country categorical variable is ready. It's actually more simple than in Python. So before selecting and executing this, let's look at our dataset. Our dataset contains our country written in text. And now let's select this, execute, and now let's look at our dataset. Perfect. Our country contains our encoded variable, and as you can see, 1 is France, 2 is Spain, and 3 is Germany. Okay, so that's all good, and now we need to do the same for the purchase column, and it's exactly the same. We're going to use the factor function. We're going to transform the text categories into numerical labels. So let's do it right now. We're going to copy this, paste it here. Here we're going to replace country by purchased. Alright, same for here. Here we need to change the levels because there are new categories, so the levels are going to be no and yes. Okay, and now of course we need to change the labels. So we're going to put 0 for no and 1 for yes. I think that's what actually makes sense. And parenthesis. Okay, and that's ready. Let's look at the dataset. The dataset contains no and yes in the purchase column. And now if I select this and execute, the dataset contains now 0 and 1. Perfect! we're all good. We encoded our categorical data in R, and now you know everything that there is to know about encoding categorical data in Python and R. So congratulations. I know this was quite a long tutorial, but we almost did the most difficult part. We are approaching soon the fun and exciting part about making models. So we are almost there. Hang on for 1 or 2 more tutorials, and this is gonna get very exciting. Thank you for watching this tutorial, and I look forward to seeing you in the next tutorial. Until then, enjoy machine learning. Hello and welcome to this tutorial. Okay, so we are almost done with part 1 data preprocessing. I can't wait to start making the machine learning models. We just need 3 more tutorials to make our dataset perfectly prepared before starting the models, and then we'll be good to go. Okay, so today we're going to talk about the fact that we need to split the dataset into a training set and a test set, and I'll explain why we need to do that right now. So let's go to Google Sheets. Well, I'm on Google Sheets, but you can be on Excel, you can be on whatever tool you want. But here is the dataset open with Google Sheets. So we have our 10 observations, and this is the dataset. This is the whole dataset. And what we should do in any machine learning models is that we're going to split this dataset into 2 separate sets, which are going to be the training set and the test set. Now, why do we need to do this? Well, when you take a step back and focus on the name machine learning itself, you understand that this is about a machine that is going to learn something. Well, here, it's your algorithm, it's your model that is going to learn from your data to make predictions or other machine learning goals. And so your machine learning model is going to learn to do something on your dataset by understanding some correlations that there is in your dataset. And imagine your machine learning model is learning too much on the dataset, like it's learning too much the correlations. Then I'm not sure its performance would be great on a new set with slightly different correlations. You know, it's like a student who is learning by heart his lesson, and then when he takes the exam, he might be in trouble because he learned too much his lesson by heart, and he does not manage to make the connection between what he learned and the exam. And it's the same for machine learning. We are going to build our machine learning models on a dataset, but then we have to test it on a new set, which is going to be slightly different from the dataset on which we build the machine learning model. So we have to make 2 different sets, a training set on which we build the machine learning model and a test set on which we test the performance of this machine learning model. And the performance on the test set shouldn't be that different from the performance on the training set, because this would mean that the machine learning models understood well the correlations and didn't learn them by heart, so that he can adapt to new sets and new situations. Okay, so that's the idea about splitting the dataset into a training set and a test set. So we're gonna learn how to do it right now on Python and R, and let's start with Python. So I'm gonna jump straight to Python, here we are. Okay, and I have my section ready, splitting the dataset into the training set and the test set. Okay, so you're gonna see that it's very simple. It's gonna take us 2 lines, and as usual, let's start by importing the library that is going to do the job for us, because we want to be efficient. The world is going so fast, so we want to solve our business problems in the most efficient way. Okay, so the library we're going to import is a new library we haven't met yet. It's the cross-validation library, still from scikit-learn. Okay, so let's import the library. So we type from sklearn that cross underscore validation. So here it is, I just have to press enter, validation, import, and now we're going to import the train test split. Remember when I told you that the library's name are quite intuitive? Well, that's the case, train test split, it couldn't be more clear. Okay, so we imported the library, we're fine with that. And now let's build our training and test sets. So what we're going to do is we're going to create xtrain, then xtest, comma, and then ytrain, and then ytest. Okay, so xtrain is the training part of the matrix of features, xtest is the test part of the matrix of features, ytrain is the training part of the dependent variables that is associated to xtrain here. That means that we have the same indexes for both with the same observations. And ytest is the test part of the dependent variable vector associated to xtest. and then we're gonna add an equal, because we're going to define these 4 variables at the same time. So train, test, split, and then we're gonna put our argument. So let's inspect it. Let's press Command I to see what we have to input. Okay, so train, test, split. The first parameter is arrays. And what is arrays? That's simply the matrix X. That is the matrix X of features of independent variables of our data set. And then Y, which is the dependent variable. So by putting X and Y, it's like we're putting the whole data set. And that's what they mean by arrays here. Okay, then the next parameter is test size. So we're gonna add here test size equals. Okay, so very simply that's the size of the test set you want to choose. So for example, if I put test size equals 0.5, that is 50%, that means that there's going to be half of your data going to the test set and half of your data going to the training set. But usually we never choose 50% for the test size, we choose a smaller percentage. A good choice of the test size is generally 0.2, like 20%, that's a good choice, or 0.25, 25%, or even sometimes 0.3. And in some rare cases you will find 0.4, but really I've never seen 0.5. So here we're going to choose 0.2, 20%. So that means that since we have 10 observations, let's go back to Variable Explorer and find the data set. We have 10 observations, so that means that once we do the train test split, we're going to have 2 observations in the test set and 8 observations in the training set. So let's click OK. And is that all what we have to input? Well, let's go back to Object Inspector to see the next parameter. Okay, so then we have train size, but since test size plus train size equals 1, we don't need to input train size, that would be redundant. But then we're going to use this parameter, and that's just for the purpose of this course, because I don't want you to worry about having different results than mine. You're going to have the same logical results, but you might have different results if we don't put a random state parameter. So we're going to use this random state and set it to the same number so that we have all the same results. So let's add here random state equals, then we can choose whatever we want. A good choice number is 42 and the regular number I choose is 0. Random state equals 0. You can put random state equals 0 in your code if you want to have exactly the same results as mine. It's really as you want. Okay, so we are done actually. That's the 2 lines that we have to write to split correctly the dataset into the training set and the test set. So let's see what happens. Let's select these lines. Okay, Command or Control plus Enter to execute. Here we are, it executed properly. Now of course, let's look at what happened. Let's go to Variable Explorer. Here we have some new variables. Remember before we had the dataset, the X matrix of features and the Y dependent variable vector, and now we also have X train, X test, Y train and Y test. So let's look at them one by one. X train. Since we chose a test size of 20%, 0.2, we would normally have 8 observations in the train set and 2 observations in the test set. So let's make sure that's the case. Okay, so we have our 8 observations in the training set. Now let's look at the test set. 2 observations in the test set, perfect. And now let's check that it's the same for Y train, 8 observations, fine, and Y test, 2 observations. Okay. Okay, now let's open the 4, X train, X test, Y train, and Y test. Okay, so to summarize what the train test split is about, here above we have the training set with the X train matrix of independent variables and the Y train dependent variable vector. And below we have the test set with the matrix of independent variables, X test, and the dependent variable vector, Y test. And so what happens is that we are building our machine learning model on this training set by establishing some correlations between the independent variables here and the dependent variable here. And then once the machine learning model understands the correlations between the independent variables and the dependent variable, we will test if the machine learning model can apply the correlations he understood based on the training set on the test set. That means that we will see if he can predict that this customer number 0 here is not going to buy the product, and if this customer number 1 here is not going to buy the product. And he's going to be able to predict that based on what he learned on the training set. So the better he learned the correlations in the training set, the better he will be predicting the results in the test set. But if you learn too much by heart the correlations of the training set, by learning them by heart and not understanding them, then he will have trouble predicting what's happening on the test set. Because since he learned by heart the correlations, he didn't understand quite well the logic and he won't be able to make good predictions. That's called overfitting. We will be talking about that in further details in the regression section, and we will learn how to use regularization techniques to prevent this. But for now, it's really important that you understand that we need to make two different data sets: the training set on which the machine learning model learns and the test set on which we test if the machine learning model learned correctly the correlations. Okay, so let's click OK and close that. We're done with the train test split in Python, and now let's do it on R. So here we are on R, the section is ready, splitting the data set into the training set and test set. And let's start coding the thing. Now that you understand well the difference between the training set and the test set, we're going to do it a little faster. So, new thing here. We have to import a library. We're going to import the library that is going to make a good split of the data set into the training set and the test set. And this library is called CA Tools. So let's import it. Here I'm going to the Packages tab to see the list of the libraries. Here you can see that the CA Tools library is here. I have it installed on the packages because I installed it before, but it's probably not the case for you if you're starting R for the first time. So we're going to install it. To install a library in R, it's very simple. You have to type install.packages and then in parentheses, quote, and then the name of the library in quote. So here we type CA Tools and we're ready to go. So then you have to select this line and press the Command or Control plus Enter to execute. Here it is, and right now it's installing the package CA Tools. Okay, perfect. So then you have to put it as a comment because you won't need to install it again. But then as you can see, we just installed the CA Tools library, but it's not activated yet, it's not selected, and we have to select it. So to select a library, you have two choices. Either you click on the box here, as you can see this generates the scripts here, or, if you have some scripts that you want to automate and execute once at a time, well, you can specify in your script that you want to include the library, and to do this you just need to type library parenthesis and CA Tools, the name of your library, not in quotes actually, this time. Library CA Tools. Okay, perfect, and now you're ready to go. We can check, CA Tools is not selected right now, and if I select this and press Command and Control to execute, now it is. Now it's selected. Okay, so now we imported the CA Tools library that is going to make a good split of the data set into the training set and the test set. So now let's make the split. So remember in Python, for those of you who followed the Python tutorial, we used random state equals 0 so that we get the same results. Well, here it's going to be the same. We're going to set a seed to have the same results, only we're going to do it now. We're not going to wait to be in the function in the library that makes the split. So to do it, we have to set the same seed, and so we can type set.seed, and in parentheses we can choose any number we want. It can be this number, that's a seed. If we both choose this number, we'll have the same result. But let's choose a more simple number. Let's choose, for example, 1, 2, 3. And now let's make the split. It's not as simple as in Python where we make it in one line. Here we're going to have to prepare the method that we're going to call split. That is the method that is going to make the split of your data set into the training set and the test set. Equals, and then sample.split. Okay, now if you want we can press F1 to see what we have to input. Okay, so see, sample.split, split data into test and train set. Let's see the arguments. The first argument is y. So that's not the same argument that we had to put for Python. In Python we had to put both the matrix of features x and the dependent variable vector y. Here we only have to put y. Only we're going to take y the following way. We're going to type dataset $purchased. because your dependent variable is purchased. Okay, so that's okay for the first parameter. And then what is the second parameter? It's split ratio. Okay, so split ratio, let's write split ratio here. And so split ratio is just a percentage of the observations that you want to put in your training set. So let's be careful. In Python we put the percentage for the test set, and here we have to put it for the training set. So remember, in Python we chose 20% for the test set, so here logically for the training set we will choose 0.8. Okay, so what will this split return? So it will return true or false for each of your observations. That means that each observation will have either true or false, and it's going to be true if this observation was chosen to go to the training set, and false if the observation was chosen to go to the test set. So let's have a look. Let's select this. Command or Control plus Enter to execute. And here it is. We have the split here. So now let's go to the console and write split. Alright, enter. Alright, you see that you have 10 values, and so true means that the observation goes to the training set, and false means that the observation goes to the test set. Okay, so now what we have to do is to create the training set and the test set separately. So we're going to do this. We'll type training set, which is going to be the name of our training set actually. Let's make it simple. So training set equals subset, parenthesis, and here as the first argument we put data set, because the training set is a subset of the data set. And here we will specify that we want the split equals true, and that's it. Okay, so that's it for the training set. Now let's copy this line, paste it here, and here we're going to change training set to test set, and of course we're going to change split equals true to false, because the test set are the observations for which the split equals false. And now we're ready. We are ready to make the split of the dataset into the training set and the test set. So let's execute these lines. Command and Control plus Enter to execute. And here we go. Test set and training set are created. Let's look at them. So let's click on the training set here and the test set. Let's move that here and that here. Okay. Let's look at the training set first. Okay, we see that we have 8 observations. Okay, good. And now let's look at the test set. Now we can clearly see that we have 2 observations with 6 and 9. Perfect. Okay, so that's it for this tutorial. You now know how to split your dataset into a training set and a test set. This is a must-do in any machine learning models. You have to test the performance of your machine learning model into a separate test set. So congratulations, now you are almost ready to begin the journey of making exciting machine learning models. We just have one thing to do left, feature scaling. You'll understand in the next tutorial why it's so important to do this. So I look forward to seeing you there, and until then, enjoy machine learning. Hello and welcome to this almost final tutorial of the part 1 data preprocessing. I look forward to being well prepared with our data to start making our machine learning models. It's going to be very fun. We just have to hold on for 2 more tutorials and then we're good to go. Okay, so today we're going to talk about feature scaling, which is very important in machine learning. I'm going to explain you why right now. So I'm going to go to Google Sheets to find our data set, and here it is. Let's explain what is feature scaling and why we need to do it. Okay, so as you can see, we have these 2 columns, age and salary, that contain numerical numbers. Let's just focus on the age and the salary. You notice that the variables are not on the same scale, because the age are going from 27 to 50, and the salary is going from 40k to like 90k. So because this age variable and the salary variable don't have the same scale, this will cause some issues in your machine learning models. And why is that? It's because your machine learning models, a lot of machine learning models, are based on what is called the Euclidean distance. If you remember that back from high school, the Euclidean distance between 2 data points, between 2 points, is the square root of the sum of the squared coordinates. Well, actually here it's the same. We have 2 variables, age and salary, so you can picture age as the x coordinate and the salary as the y coordinate. And in the machine learning models equations, some Euclidean distances between observation points, for example this one and this one, are computed based on these 2 coordinates. And actually, since the salary has a much wider range of values, because it's going from 0 to 100k, the Euclidean distance will be dominated by the salary. Because, for example, if we take two observations, for example, this one, the ninth one, and the third one, well, the Euclidean distance will compute the difference between this salary and this salary. So let's compute it. That's about, okay, so this minus this one. As you can see, this is 31,000. If you put that in square, okay, let's see, up, square, that gives this. And now let's take for the same two observations the ages. So let's compute. Equals 48 minus, it was this one, right? 27. Okay, that's the difference. And now let's take the square. Equals this square, 441. So you can see very clearly how this square difference dominates this square difference. And that's because these two variables are not on the same scale. So, you know, in the machine learning equations, it will be like this doesn't exist because it will be dominated by this. So that's why we absolutely need to put the variables on the same scale. That is that we're going to transform these two variables and they're going to have values in the same range. For example, they're going to have values from -1 to +1 here, and same here, -1 to +1, so that we don't get this sort of problem with a huge number here dominating a smaller number here, so that eventually the smaller number doesn't exist. There are several ways of scaling your data. A very common one is the standardization, which means that for each observation and each feature, you withdraw the mean value of all the values of the feature, and you divide it by the standard deviation. So that's the first type of feature scaling, and another type is normalization, which means that you subtract your observation feature x by the minimum value of all the feature values, and you divide it by the difference between the maximum of your feature values and the minimum of your feature values. Don't worry if you're not very comfortable with the mathematics here, but what you need to understand is that we are putting our variables in the same range, in the same scale, so that no variable is dominated by the other. Okay, so let's do it right now. Anyway, you're going to see how the variables are going to be transformed. You're going to see how they go from having large and very different values to small and same values. We're going to see that right now in Python and R. So let's do it. Let's start with Python as usual. Here we are in Python. The feature scaling section is ready with the command feature scaling. So let's start right now. So as usual, we're going to import a library to do this. And we know this library, we already saw it. It's the Preprocessing library. And from this library, we're going to import the standard scaler class. So let's do it. We're going to import sklearn.preprocessing. So that's the preprocessing library. Import standard scaler. All right. So that's the class we need to import. Then, as usual, we're going to create an object of this class, and we're going to call it sc for scale _x, because you will see later that we might need to create another object that will scale the dependent variable vector, but so far we will only need to scale the x matrix of features. So scx, and then here standard scalar, which is a class, right? And parenthesis, okay. And now, very simply, we will directly fit and transform our training set and our test set. So let's do this. We're going to transform xtrain, so we will recompute xtrain because we want it to be scaled. And so to do this, we're taking our object sc_x, and then we're calling the method fit and transform. So that's very important to understand that. When you are applying your object, standard scalar object, to your training set, you have to fit the object to the training set and then transform it. And you're going to see that it's not going to be the same thing for the test set, because we will only transform the test set, but for the training set we need to fit it and then transform the training set. So, okay, so here we will just need to add as an argument xtrain, and that's it. And now, same for the test set. So we are going to copy this line, paste it here, and here, test. and then X test here as well. And now, as I just said, for the test set we don't need to fit the SCX object to the test set because it's already fitted to the training set. So here I will remove fit and we're good to go. Okay, now there are two questions that we can ask ourselves. The first one is really important and you will find a lot of these questions on Google. This question is, do we need to fit and transform the dummy variables? Because as you can see, dummy variables, okay, let's change the format here for a second. 0, okay. As you can see, the dummy variables takes values either 0 or 1. So do we need to scale that? Because it seems to be already scaled, right? So if you ask this question to Google, you will find several answers. You will find several teams for that. Some will say that no, you don't need to scale these dummy variables. Some say that yes, you need to do it because you want some accuracy in your predictions. And if you're interested in my opinion, I would say that it depends on the context. It depends on how much you want to keep interpretation in your models. Because if we scale this, it will be good because everything will be on the same scale, we will be happy with that, and it will be good for our predictions, but we will lose the interpretation of knowing which observations belongs to which country, etc. So it's as you want. It won't break your model if you don't scale the dummy variables because they will be actually on the same scale as the future scaled variables here, which will take values between -1 and 1, I think, we will see. But here, since this is our final tutorial and we won't have any interpretation to make, we will scale those dummy variables. Alright, so that's how you feature scale. Now let's not forget to select this and Command and Control plus Enter to execute. And here we go. Okay, so now let's check our X-train and X-test. Let's double click on X-train. Okay, here's X-train. As you can see, all the variables now belong to the same range, to the same scale. As you can see, all the variables seem to be between -1 and +1, so that's perfect. That will largely improve your machine learning models. And besides, I forgot to mention that even if sometimes machine learning models are not based on Euclidean distances, we will still need to do feature scaling because the algorithm will converge much faster. That will be the case for decision trees. Decision trees are not based on Euclidean distances, but you will see that we will need to do feature scaling because if we don't do it, they will run for a very long time. Okay, and let's have a quick look at X-test. That's X-test. It's also feature scaled. And you have to understand that the feature scaling here in X-test is the same as the feature scaling on X-train, simply because the object standard scaler was fitted to X-train. That's why it's important to fit the object to X-train first, so that X-train and X-test are scaled on the same basis. Okay, and now I promised you another question. The other question was, do we need to apply feature scaling to Y, the dependent variable vector, so to Y-train and Y-test? Here, as you can see, the dependent variable vector is a categorical variable because it's taking only two values, 0 and 1. And now the question is, do we need to apply feature scaling on this one? Well, the answer is no this time. We don't need to apply feature scaling to this one. However, here we don't need to do it because this is a classification problem with a categorical dependent variable, but you will see that for regression, when the dependent variable will take a huge range of values, we will need to apply feature scaling to the dependent variable y as well. But let's not worry about that for now. You will see how we will do it in the regression section. And actually you will see that it's very simple. We will just be doing the same thing as we did for X-train and X-test. Okay, so that's good for Python. Congratulations, now you master feature scaling in Python. So let's move on to R. So here we are on R, and now that you understand feature scaling, let's apply it to the training set and the test set. Here we will just write two lines of code, which are, so the first line is training set. So the training set already exists, right? It's this one, the training set. As you can see, it's not scaled. It contains the raw values. So training set equals, and simply now we're going to write scale, and then training set. That's all. That scales your training set. Isn't it great? And same for the test set. We will copy this line, paste it here, and we will change training into test, and here as well. Okay, so here I just wrote this. There is something important to understand. This will be the feature scaling block of code that we will be using in our template. However, let's see what happens when I select this code and execute it. So let's select this, execute. Okay, as you can see here, I obtained two errors. Error and call means X must be numeric for the training set and the test set. Can you guess what the problem is? The problem is that, okay, well, it tells us what the problem is. It tells us that X must be numeric. But what does that mean? Well, first, what is this X? X is, for this line of code, the training set, and for this line of code, the test set. So let's forget the test set for a second and let's focus on the training set. So X is a training set and it says that the training set must be numeric. So let's look at our training set. Okay, well, the training set looks numeric, right? Here we have numeric values, numeric values, numeric values, numeric values. But no, actually, there are two columns that don't have numeric values. It's this one, the country, and this one, purchase. And do you remember why? Well, it's because before we had the country written in text and the purchase column written in text with yes or no, and we changed that by putting the categories as factors. That's what we did here, as you remember. Dataset country equals factor of the different levels and labels. And a factor in R is not a numeric number. And when you apply the scale here, X must be numeric. That means that all the columns in X, that is the training set, must be numeric. So this time we're going to exclude the categories from the feature scaling. We're not going to apply feature scaling on those columns. So that's very simple. All we need to do is to take the columns we're interested in, which are, well, the indexes of the column we want to scale, which are indexes. So indexes in R start at 1, so that's 1, 2, 3. So that's the second and third index we want to take to scale the age and the salary columns. So 2 and 3, let's input it. We need to specify here 2, column 3, and that gets what we want. So now I'm going to copy this, copy, paste it here, here, and here. Alright, and now it's ready. Let's have a look at the training set and the test set. So not scaled, not scaled. Let's go back to our code. Let's select this, and now we shouldn't get an error. Command and Control + Enter to execute. Here we go, it executed properly. And now let's look at the training set, all scaled properly, perfect. And the test set, all scaled properly. Perfect, now our data is ready to offer a good precision, a good accuracy, and a fast work of the machine learning models. And by that I mean that the machine learning models will converge rapidly. Okay, so that's it for feature scaling. Now you know how to apply feature scaling to your data in Python and R. Congratulations, and mostly congratulations because we did all the required steps to pre-process our data. Feature scaling was the last one because the next tutorial will be about this data pre-processing template, and I will just explain how we are going to use it in our machine learning models. It's going to be very fast and practical. So we are done with the data pre-processing. Congratulations, you did the most difficult part, and now it's time to have fun. It's time to start making the models, and I can't wait to start them with you. So thank you for watching this tutorial. I look forward to seeing you on the next one, and until then, enjoy machine learning. Hello and welcome to the final tutorial of part 1 data pre-processing. We finally completed all the steps that there is to do to prepare any data set on which we will build our machine learning models, and now what we only need to do left is to prepare the data pre-processing template, because we learned a few stuff. We learned how to import the libraries, to import the data set, to take care of missing data, to encode categorical data, to split the dataset into the training set and the test set, and to apply feature scaling to put all of our variables on the same scale. However, in the data pre-processing template, we're not going to include all of these. We're only going to include the importing the libraries. Then of course you need to import the dataset. Then regarding missing data, I just wanted to show you how to take care of that in case you have some missing data in your dataset, you know, in your work. So we are not going to include this in the templates. It's just good to know how to take care of this. But then we will focus on the machine learning models themselves. And if in your work experience you encounter missing data, you know how to handle this, any missing data issues. Then as for categorical data, we won't include it either in the template because we're going to find very few examples of data where we have to encode the data. There will be some examples, but we won't include it in the templates because our data sets are going to be well prepared so that we can mainly focus on the machine learning models and get the maximum fun. And then, of course, we will include this in the template, splitting the data set into the training set and the test set, because that's a very important step. You need to split your data set between training and test because you need to evaluate your model on a different set than the set on which you built your model. And feature scaling. Okay, so feature scaling, I hesitated to include it in the template, but we are going to include it, only we're going to put that as comment. Because you're going to see that there are several libraries in R and Python, and some of them require us to apply feature scaling to the data, and some of them don't. So most of them don't actually, most of them take care of that for you, you don't have to do it manually. But you will see that some libraries don't apply the feature scaling. I won't tell you which models there are right now because I will let you find out the surprise, but keep that in mind and you will see that sometimes we will have to use feature scaling. Okay, so let's start making the template. It's going to be very quick. So let's make it first on Python. Alright, so what did we say? Importing the libraries? Yes, we keep it. Importing the dataset? Yes, that's a compulsory step. If we don't import the dataset, we cannot make any machine learning models because the model won't have anything to learn. Then taking care of missing data. Okay, that was just to show you, so we are going to remove this. Alright. However, I put separate Python and R files in the part1 data preprocessing folder. Just in case you need to take care of missing data, you can always use this code. It's in a separate file, but we won't include it in the template. Alright, now encoding categorical data. Okay, so we will encounter very few examples where we will need to encode categorical data. So same for the missing data, we're going to exclude it from the template and I put it in a separate file. Okay, so the template is getting ready. Of course, we're keeping this section, splitting the dataset into the training set and the test set. That's absolutely necessary. There will be one or two examples where we won't do it because the context will be quite particular, but in general you will need to do this. And finally, feature scaling. Okay, so as I said at the beginning of this tutorial, we are going to keep that, but we are going to put that in a multi-line comments because most of the time we won't need to do feature scaling because feature scaling is a tool included most of the time in the machine learning libraries. Okay, so to put something as a multi-line comment in Python, you have to put all this section between 3 double quotes. So just like this, 3, and then you have to close it with another 3 double quotes. Alright, now all this section is in comment. Perfect! So the template is ready, we can save it. I already called it data preprocessing template. We can save it and now the template is ready. So what we'll do at the beginning of every machine learning model is that we will take all of these from this data preprocessing template Python file, copy this, and we will put it at the beginning of our machine learning models before building the model itself. So you will see, we'll be very practical. This will save us a lot of time and we won't have to change much stuff. Like for example, sometimes we will change the test size here. We will have to change sometimes the index here for the y dependent variable because we might have more than 3 independent variables because as you can see here, we have 1, 2, 3 independent variables, but we might have less than that or more than that. So we will have sometimes to change this index here. However, most of the time we won't need to change this because the -1 here means that we are removing the last column of our data set. So that means that we're taking all the feature variables, that is all the independent variables. So we should be fine with this. And of course, we will need to change the name of our data set. And that's all. So basically, in worst case scenario, we will only need to change 3 things. The name of the data set, the index in the dependent variable column, and maybe the test size. Alright, so that's it for Python. The data preprocessing template is ready. I can't wait to show you how it will save us a lot of time to make our machine learning models. And now what we're going to do is do the same thing on R. You see, it's going to be the same template. Let's do it right now. Let's jump to R. Alright, so here is all the steps that we did together. So importing the dataset, yes, we're keeping it, of course. Taking care of missing data, that was just to show you we won't need it in the future. But you will probably need it in your future, but in the future of this course we won't need it, so we will remove it. Encoding categorical data, same here. We will have to do it once or twice, but not all the time, so we will remove it. And as I told you, I'm putting this in a separate file so that you can still use it if you need it for your work. Alright, and now I think we have everything. Splitting the data set into the training set and test set, of course we're keeping that. And feature scaling, as for Python we're going to put that in comment. So the 3 double quotes is not a way to put multi-line comments in R, so unfortunately we cannot do it. What we need to do is, this is a good trick, you select the 2 lines here and then you press Command and Control plus Shift plus C, and that puts all your lines in comment. And eventually we'll just add a final touch to this template, which is the case where we need to take a subset of our data set, and in that case we will add the line dataset equals, then we take the same data set and we use the square brackets to select the indexes of the columns we are interested in to build our model. So let's just put some numbers here, and if we need to select specific columns of interest in our future data sets, we will change those indexes. But for now, let's just put this line in comment. Alright, so the template is ready on R as well. We are ready to start our machine learning models. You have no idea how I'm excited about that. I can't wait to show you how it's going to be a lot of fun. We're going to make awesome predictions. You know, we will have some kind of scenarios, business problems, and we will have to solve them, and we will use the power of machine learning to solve these problems. You will see how machine learning is powerful. It gives you amazing predictions, amazing results, and keep in mind you will never be lost because we will always know what we are coding, we will always visualize it. There will always be some visual graphics of what we're doing when we make every machine learning model. So I can't wait to start this with you. This was the boring part, but a very important part to do, so that's great that we did it, and now it's time to have fun. So thank you for watching this data preprocessing tutorials. Congratulations for completing this part. You are now ready to make machine learning models, and I look forward to seeing you in the next part. Until then, enjoy machine learning.